this video, we will talk about tangent lines and circles. Couple things. A tangent to a circle is a line that intersects a circle at one exact point. Only one, not two, doesn't cross. It's only touching that one circle at one single point. Okay? So, and if I have line BC, so this is my line BC right there, is tangent to circle A. This is circle A, this is line BC at point B. So we know that is a tangent because it only touches circle A at one exact point. So line BC right there is perpendicular to radius AB. Okay, that means that angle right there is 90 degrees at point B. Okay, and we're going to use this a lot to the point that you're going to get tired of it. And the other thing that we need to know is if I have two line segments, if they're tangent, so remember that this is 90 degrees, this is 90 degrees, because I know if a tangent right there, that makes 90 degrees. Okay, with that, it intersects the circle at a 90-degree angle. Okay, so if two line segments are tangent to a circle and share a common endpoint outside the circle, so I have this line segment, and the point is right there on the outside, then the two line segments are congruent. I already know these two are 90 degrees because of that definition right there. But if they share the common point outside the circle, then they're congruent. Okay, we're going to work 4 examples based off these two things. Okay, so I have line NP is tangent to circle M. That's line NP right there. Okay, it keeps going, but we're just looking at the segment right there. We're trying to find the distance from M to P. So we're trying to find the distance from here to here. Okay, I know by definition that if this line right here is tangent to the circle, I know that's 90 degrees right there. Ta-da! Pythagorean theorem. Okay, so I know a squared plus b squared is c squared, but which one is what? So let's say that a squared is 5 squared, b squared is 12 squared, equals c squared. And c squared in this case is going to be MP, and that's what we're looking for. Okay, so 5 squared, 25, 12 squared is 144, and c squared. So c is the same thing as MP, so MP squared. So 25 and 144 is 169, equals MP squared. But I'm only trying to find MP, so you take the square root. Therefore, the length of MP is 13. So the math is not complicated, but you do need to keep in mind these two definitions about the tangent lines. Okay, 3 more. I have 2 lines right here, KM and MN are tangent to circle J. I know, as soon as I see the tangent right there, I know these guys are 90 degrees. Okay, what is the measure of angle M? So we're trying to find this angle right there. So right there I have a quadrilateral. I know it's a kite, but we're not going to talk about quadrilaterals today, just what we need to know. I know that the sum of all the angles from a quadrilateral, they add up to 360. Okay, I have 125 degrees right there. I have 90 degrees from that. I have 90 degrees from that. And I have the degrees of angle M, and that's what we're looking for. Measure of angle M. Okay? So we have 125 plus 90 plus 90. I have 305 plus measure of angle M minus 305 from both sides. I have the measure of angle M is 55 degrees. Too easy. So number 3, I have two lines, line KM and line MN. They're both tangent. Okay, to circle J. That's circle J. What is the length of line segment KM right there? Now, they're both tangent. Okay, and look, they share a point that is outside the circle, just like our second definition right there. So the two line segments, and they share a common point outside the circle. I know by definition that this line segment is congruent to that line segment. Voila, easy. So now I just set them up equal to one another because they're congruent. So minus 6x from both sides. And then minus 3. So x equals 5. But that's not the question. The question is asking for the length of Km. So Km is right there. So Km is 7x plus 3. And I know x is 5. So substitute that. So the length of line segment KM is 38. Last one. So we have line WX is tangent to circle V. And as soon as I see that tangent, I know 90 degrees right there. What is the radius? Well, I'm looking for this right there. And I know this is congruent to that. We're missing some stuff here. Not really. I have this leg, I have part of the hypotenuse, but I also know this is congruent to this because that's the radius. Okay, so here we go. I know a squared plus b squared is c squared. I know a is one of the legs. Okay, so 42 squared plus b, that's this one right here. Let's just call it r because that's the radius. So r squared. Now the hypotenuse is this whole thing right there. It's whatever r is plus 18. Okay? Now, you can do FOIL here, or you can do the binomial expansion. It doesn't matter. I'm going to do the box here, just because. So, and I know r plus 18 squared, that is r plus 18 times r plus 18. If you don't want to do the box, don't do the box, do FOIL, that's fine. R times r is r squared, multiply 18r, multiply 18r, multiply 324. Combine like terms, so r squared plus 36r, 324. Okay, so I know this is the same as this. So 42 squared, 1764, plus r squared is this right here. R squared, 36r, 324. Okay, so minus r squared from both sides. Now here I have 0. So 1764 equals 36r plus 324. Minus 324 from both sides. That's 0. 36r. And here I have 1440 divided by 36. That's 1. So r equals, what do we have there? 40? 40 feet. So 40 feet is the radius of this circle with that tangent right there. Hope this helps.